So today we're going to discuss about how to find the areas of specific triangles, and we know the easiest way to calculate the area of a triangle is 1/2 base times height. There's going to be a couple of special formulas that I'm going to give you, which you can memorize or not, depending on what you want to do. There's going to be multiple ways to find these areas and use which is most beneficial for you. So let's take a look at this problem here. We've got finding the area of ABC, where A is 25 degrees, B is 21.1, and C is 16. So here's 25 degrees. Call that A. And let's say B is right here, 21.1. And we'll call C 16.5. So if I was going to do this problem and I didn't know any better, I would take and construct an altitude and find this height, and then just do 1/2 base times height. Now to find that height, I know I have this right triangle over on the left where I have a hypotenuse and I'm looking for the opposite. So that sets up itself for a sine ratio. Sine of 25 is equal to the opposite over the hypotenuse. And then I can just calculate that on my calculator, which is going to give me about h being roughly 0.79. And then I want to find the area of the triangle, so I go 1/2 the base, which is 21.1, times the height, which is 0.79. That's my area, which gives me roughly 8.33 square units. And that's my area. Now, like I said, if I look at this problem and just have to wing it, this is how I do it. Now, there's a special formula that says if you're given a side angle side situation, then what you can do is find the area by taking 1/2 the two sides, their product, and multiply that by the sine of the angle included between the two sides, which is basically what I just did without knowing this formula. So if I get another problem that has an angle A, and in this case we're going to have angle A being 120, and then side B will go 13, and side C, I'm sorry, that's side B being 10, side C being 13, then all I'd really have to do, since I have a side angle side, is take and go 1/2 two sides and their product, multiplied by the sine of the angle between. And that would get me my area. Which in this case is about 56.29 square inches. So let's move on. In this case, we're given a triangle with three sides. So side A of 10, side B of 14, side C of 16. And again, I could calculate 1/2 base times height. The problem would be quite a bit more difficult because I'd have to use law of sines to find a missing angle, then draw my altitude, and go from there. But still, it only requires two calculations. So in lieu of that, we can use this thing I would hope you would have learned in geometry called Heron's theorem. And Heron's theorem says that if we take the perimeter and take half of that, call that the semi-perimeter, and then use that in a calculation of the semi-perimeter multiplied by the semi-perimeter and the difference of each side, then we get the area of the figure. So in this case, I have a semi-perimeter equaling half my area, or half my perimeter, sorry. So my perimeter in this case is 40, and making my semi-perimeter 20. And if I want my area, I'll just take that value of 20, multiply it by 20 minus the difference of each side. This would be pretty easy to do without a calculator and find the exact value. But the book's probably going to round this off anyways, so we can go right ahead and do that. So the area in this case is roughly 69.28 square units. Let's do one more just for kicks. Again, got A, B, and C. Call this 13, 15, 15, and 18. Use Huron's theorem, so take half of the perimeter. Perimeter is 28, 36, 46. So 23 is half the perimeter. Then we go 23 multiplied by 23 and the difference of each side. Square root all of that, and that gives us our area. And in this case, that's going to be about 95.92 square units. Like I said, pretty quick day. Do your lesson summary and your My Math Lab, and we'll talk to you tomorrow.